Question 6a. Use logarithm tables to evaluate this problem. Solution. The question can be broken into 3 parts for easy understanding. The first part is without the power and cube root. The second part is to apply power operation on the first part, and the third part is to apply root operation on the second part. Let us put all of these together to get the solution. The solution continue. This is the first part. We consider the numerator. The first number there is 565. When you are to get the logarithm of a number, you do two things. You get the characteristic or integer part and the mantissa or whole number or decimal part. Mantissa or decimal part. To get the integer part or characteristic part, you subtract 1 from the number of digits in the whole number part. We have 3 digits. If you subtract 1 or you write this number in standard form, the power to base 10 is going to be 2. Or if you subtract 1, you are still going to have 2 as the characteristic. Then followed by decimal point. Next thing is to get the mantissa. To get the mantissa, you strictly use the logarithm table where you check 56 under 5, no difference. The operation of the logarithm table is to 4 digits, whereby you take the first 2 digits from the left under the third, difference the fourth. Since there is no fourth digit here, we consider 56 under 5, and that is 7520. The next number is less than 1. To get the integer part easily, you write the number in standard form. If you do that, the power to base 2 is the integer part, and that power is -2, written as bar 2. For the mantissa, you check 53 under 6. You have 7292. Multiplication implies addition of log values. If you add these two results, you have this result. Let us take it forward. The denominator is this. The integer part is 2. If you subtract 1 from the 3 digits in the whole number part. For the mantissa, you check 24 under 9, difference 1. That is 3964. Let us take it under the first result. Division implies subtraction of log values. So if you subtract these two results, you have this for the whole of part 1. Part 2 is power operation, and the power is 2. Power operation implies multiplication of the log values. So you multiply this result by 2. Starting from the right to left, you have this result. The next step is root operation. You carry out root operation on part 2. What you are dealing with now is the result. So cube root means you divide the result from part 2 by 3. Now, you cannot divide part 2 by 3 easily. Here, we try to ensure that when we divide, our answer is a whole number, not decimal. So, you transform bar 2 to bar 3 plus 1, so that 3 can divide by 3. you see how or why we have to write bar 2 as bar 3 plus 1. You must know that anything you are transforming into, if you reverse it, you get the original 10. Now we divide. Bar 3 divide by 3, you have bar 1. Now if you divide 1 by 3, is 0 remainder 1. If you add that 0 to bar 1, you still have bar 1, then decimal point. You take remainder 1 to 1, it becomes 11. Divide by 3, you have 3 remainder 2. Remainder 2, you take it to 6, it becomes 26. Divide by 2, you have 8 remainder 2. Remainder 2, take it to 9, it becomes 29. Divide by 3, you have 9 remainder 2. Remainder 2, take it to 6, it becomes 26. Divide by 3, you have 8 remainder 2. No other digits. If you wish to continue, because of the decimal point, you can add 0 to remainder 2, it becomes 20. Divide by 3, you also have 6, and so on. Next thing is to check the antilog of this result. In the antilog, we are interested in the decimal part only. So you take 0.38 under 9 difference 8. That will give 2454. Next thing, this integer part of bar 1 simply means you should have 1 0 to the left. 1 0 to the left. So you have 0. Then the point comes after the first 0. So you have 0.2454. Now, assuming this one is positive, you need to add 1 to it. Why? Because you subtracted from here to get this 2. So assuming bar 1 is plus 1, you need to add 1, and you move, that means it will be 2. So you have to move 2 steps forward from behind. But because it is bar 1, it implies 1 0 to the left. If you have bar 2, it implies 2 zeros to the left, and so on. So the final result is 0.2454. Question 6b. An arc AB subtends an angle of 300, an angle of 36 degrees at the center of a circle of radius 7 cm. Calculate the area of the minor sector. This diagram illustrates the information. All we have, the angle precisely is in the minor sector, so no other operation is needed. But assuming you are asked to get the area of the major sector, you need to subtract the given angle that is in the minor sector from 360 degrees. But since we have it in the minor sector, we work with it the way it is. Area of minor sector, the formula is this. You replace theta with 36 degrees over 360 degrees times pi times 7 square. That is the radius. If you simplify this, you have 1 over 10. 7 square is 49. Divide by 7. 7 is remaining. And of course, you have 22 in that place. If you multiply and divide, you have 15.4 square centimeters as the area of the minor sector.